Say freeze! So, welcome guys sa isa na namang nakakamangha, nakakapagbagang damdamin at kagila-gilalas na eksperimento. Ayan! Ngunit, bago ang lahat ay akin munang ipapakilala ang aking mga kagrupo na kasalukuyang nasa kani-kanilang mga bahay. Ako nga po pala si Mira ang naatasang mag-vlog ngayon. Samantalang si Ara ang gagawa ng eksperimento. Si Mark Raywin at si Karima ang mag-i-explain ng gagawin nating eksperimento. Samantalang kami kasama si Dana ang nagtulong-tulong para matapos ang activity sheet. And lastly, si Mika ang mag-i-edit ng video na ito. Ang focus ng usapan natin ito ay tungkol sa tubig. Bata pa lamang tayo hanggang ngayon na nagkaedad na ay patuloy pa rin tayong pinapaalalahanan na uminom ng 8 hanggat 10 basong tubig araw-araw. Ito raw ay para mapalitan ang nawawalang tubig sa ating katawan kapag tayo ay gumagawa ng mga aktibidades tulad na lamang ng pag-iihersisyo. Pero, bakit nga ba ito mahalaga? Ano bang meron sa tubig? Ano bang meron sa kanya? Nawala ako. Water is a fundamental requirement for life. It also plays a role in how biological molecules assemble to form larger structures or undergo chemical transformation. Water itself, or its hydrogen or hydroxylic ion constituents, participate directly in many biochemical processes. Water has a higher melting point, boiling point, heat of vaporization, heat of fusion, and surface tension than most common liquid, all of which values can be described to the extensive hydrogen bonding interactions present in liquid. Sa eksperimentong ito ay may matutuklasan tayong 3 konsepto patungkol sa tubig. Ito ay ang supercooling, crystallization, at exothermic chemical reactions. So, handa na ba kayo? Ipagpatuloy ang panonood.
Atin nang simulan ang gagawin nating eksperimento. Ngunit bago ang lahat, alamin muna natin ang mga materyales na ating gagamitin. Kakailanganin natin ng 1 litrong suka at baking soda. Ito ang mga hakbang para sa gagawing eksperimento. Una, ibuhos ang 1 litrong suka sa kasirola. Pangalawa, idagdag ang 4 na kutsarang baking soda at ihalo itong mabuti. Pangatlo, pakuluan ang pinaghalong suka at baking soda sa hindi masyadong malakas na apoy. Alisin ito kapag may namuong crystal skin sa ibabaw o di kaya'y kapag mayroon na lamang natitirang 100 to 150 ml na solusyon sa kasirola. Pang-4, ilagay ito sa isang baso at ito'y takpan agad upang maiwasan ang patuloy na pagsingaw. Pagkatapos, ilagay ito sa ref upang ito'y lumamig. Kumuha ng mga kristal na namuo sa ginamit na kasirola at ilagay ito sa isang plato. Dahan-dahang ibuhos dito ang malamig na solusyon na kinuha sa ref.
A A few moments later.
Makikita natin na may nabuong hugis matapos ibuhos ang solusyon.
What is the science behind hot ice? The sodium acetate solution in the refrigerator is called a supercooled liquid. That means the sodium acetate is in liquid form below its usual melting point. Once we touch, bump, or add a small crystal, the liquid crystallization will begin, so the liquid will change to a solid. When the molecules in the solid, or the sodium acetate, are in a solution, they normally are surrounded by solvent or water molecules. Occasionally, a few solute molecules will bump into each other and stick together for a little while, but eventually break apart. If enough solute molecules stick together, they can overcome the forces in the solvent that would normally break the solute molecules apart. Once this happens, this clump of solute molecules serves a place known as a nucleation site for other solute molecules to cling to, and a crystallization process takes off. The sodium acetate powder we placed on the plate acted as a nucleation site or seed for dissolved sodium acetate in the solution. The crystallizing sodium acetate releases energy in the form of heat and is an example of an exothermic process. Sodium acetate is often used in hand warmers, and it releases heat when crystallizing.
These products consist of a concentrated aqueous salt solution, supersaturated solution of sodium acetate, together with a flexible metallic activator strip in a sealed flexible container. The activator is a thin metal piece with ridges and a specially roughened surface. The flexing causes metal-to-metal contact that releases one or more very tiny particles of metal from the roughened surface. This acts as a nesting site for one crystal deposited from the solution, and all of the crystals fall out instantly. Hand warmer concept. Supercooling. Salt solutions that have been processed in such a way that their temperature can be lowered well below their solidification or melting temperature and still remain in liquid are defined as supercooled or metastable liquids. Crystallization. The solidification process is a rapid crystallization that releases a large amount of heat at the salt solution's normal melting temperature. Exothermic reaction. Heat is released during the precipitation of crystals.
What chemical reaction occurs when you combine vinegar and baking soda? When vinegar and baking soda are first mixed together, hydrogen ions in the vinegar react with the sodium bicarbonate ions in the baking soda. The result of this initial reaction is two new chemicals, carbonic acid and acetate. The second reaction is decomposition reaction. Why do we need to boil the solution of vinegar and baking soda? We need to boil the solution because we need to remove excess water. The water keeps the sodium acetate from forming crystals because the mixture must be concentrated enough for it to build crystals. What makes the ice hot? The process of crystallization is exothermic. It releases heat to its environment. When the supersaturated solution was triggered, solid will come out of the solution, causing an increase in temperature, explaining why the ice is hot even though the supersaturated solution is initially cold. How water molecules affect the formation of crystals. The sodium acetate contains water. If the solution is dilute, there is a need to reduce some of it to keep the sodium acetate from forming crystals.
Ayan! Sana marami kayong natutunan. Maraming salamat sa inyong panonood. Hanggang sa muli!